Hi guys, so we're going to be taking a look at the first part of the math reasoning. This is on page 63 of your textbook. So we're going to start with this investigation. Now the first part of the investigation is talking about how if I have a circle that is created on the right hand side here, I have the origin point or the center of the circle is O. I have this diameter is created going from A to B. And then I have a third point that's on the circumference called point C. Now it asks us to measure out using a protractor what the angle is from A to B to C, but I'm just going to tell you. The angle here is 90 degrees. If we create a new point of D, which is also on the circumference of the circle, let's make D over here. If I connect D to both A and B, then I still have an angle of 90 degrees. I can pick any other points that I want. So let's do another point. Let's make a point of E down here. And if I connect E to A and B, conveniently enough, this also gives me an angle of 90 degrees. What conclusion can you make based on the observations from the work and the answers? If I have a point on the circumference of a circle, and I connect it to the endpoints of the diameter, it will create a 90-degree angle. And this is true every single time. No matter where I'm connecting it, it's always going to create that 90-degree angle. Let's take a look at another example down here. Bruno is investigating a fabric design for his new furniture he's making. The original design is based on a trapezoid. His first two complete sketches and a third incomplete sketch are shown. So we have the original trapezoid. Then in sketch 1, we can see that we've added two more smaller trapezoids. In sketch 2, we've added more smaller trapezoids on top of the new ones that were created for sketch 1. And so if I go to sketch 3, suddenly I'm going to create new trapezoids for all of the trapezoids we added in sketch 2. Sorry, they're not the prettiest trapezoids, but that's okay. So in sketch 1, we've added 2 new trapezoids. In sketch 2, we've had 4 new trapezoids. In sketch 3, we added 8 new trapezoids. Once we get to sketch 4, we're going to add 16 because we can see the pattern. We have 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, which means if I get to 5, I'm going to have 2 to the power of 5 new ones added because I'm multiplying by 2 every single time, and I get 32. If I go up to 6, I'm going to have 64. Based on the table, what conclusion can I make about the number of trapezoids to be added in the 10th sketch? Well, the number of new trapezoids will be 2 to the power of 10, or 1,024. We can see from the pattern, if the pattern is going to continue on, we can use that to logically state, well, what's going to happen next? All right, So the first big term that's going to be really important for this unit, we call it inductive reasoning. In the investigation, we based our conclusion on the patterns and observations we made. This is an example of inductive reasoning. For inductive reasoning, we're always going to assume that whatever pattern is established is going to continue. We know that's not always true, but this is just a general conclusion or generalization, or as we like to say, educated guess, based on experience, observations, or patterns. The conclusions are always going to be referred to as conjectures. There's another important term that we need to know. We're talking about conjecture. A conclusion, generalization, or educated guess which is arrived at by inductive reasoning is called conjecture. So anytime that we only have certain examples that exist and we are making guesses based on what's going to happen with other cases will be forms of conjecture. Conjectures may or may not be true. Therefore, basing a conclusion on inductive reasoning alone is not a valid method of proof. For example, if we're getting into this, if I said that I had a student who was late on Monday, on Tuesday, and on Wednesday, then I could assume that that same student will be late on Thursday, but it's very possible he could show up on time. So just because a pattern has been formed does not mean that the pattern will always necessarily maintain. So if we get into example 1, how did you use inductive reasoning to arrive at a conjecture from part 1 of the investigation? Well, the angles we looked at were 90 degrees. So it seemed like they would always be 90 degrees. We're doing the inductive reasoning to arrive at the conjecture in part 2. Each new sketch doubled the new trapezoids. So we continued to multiply by 2.